Okay, lesson number 14. We're finishing up probability here. Expected value, okay? This shouldn't be too bad, actually. I think this is a little bit easier if you've been on the ball with what we've been doing. Okay, so I'm going to kind of give you a formula, expected value. It's going to equal the probability times the result, okay? In other words, what's the probability of it happening multiplied by what you kind of get when it happens, okay? So we're going to talk about kind of like different games and find expected value. And then I'll tell you what it actually kind of means in common language once we get an answer here. So here's, I think we got 3 examples. Number 1, you roll a die, actually. Singular of dice is die. If you get, this is a really simple one. If you get a 1, you win $8. Otherwise, you lose $1. So it's kind of like you pay $1 to play the game. Okay, I'm encouraging you guys to do gambling. Unfortunately, no, gambling's bad. Don't do it. Just lose money. But in this case, this might actually not be a bad game here. So let's probability or expected value. We take the probability times the result. So if you get the probability of getting a 1 is a 1 out of 6 chance times the result, $8. Okay, plus what's the probability of you losing? Okay, this otherwise part. Well, if anything else comes up, right? 2, 3, 4, 5, or 6 comes up, right? 2, 3, 4, 5, 6, 5 out of 8 chance, 5 out of 6 chance that you're going to lose, times lose $1, -1. Honestly, I would just say, just to make it simple, let's just change everything to decimals. I mean, you could do that pretty easily without changing to decimals, but I'm just going to do decimals. So 1/6, 1 divided by 6 is 0.166. 7 times 8, and then 5 out of 6. You got about an 83% chance, 0.8333 times -1, and then we're going to multiply that all out. Okay, that's obviously -0.833. Okay, so I'm kind of rounding to the nearest hundredth now. Add those together, and actually subtract them, but 0.1 or 1.33 minus 0.833. Okay, 0.497. Okay, what's that mean? It means it's actually a game where you're going to come out ahead because this is positive. So this means you come out ahead about 50 cents per play. Okay, this would be a game, if you did play it, you would come out ahead on average 50 cents per play, 49.7 cents per play. Okay, this is the expected value of each play. Okay, so if you played it 10 times, hey, you might be $5 ahead. I mean, on average, that's not guaranteed. All right, let's look at a little bit tougher one. Number 2. Let's say you flip 3 coins. If you get all tails, you win $10. Otherwise, you lose $2. It costs $2 to play the game, basically. Okay, expected value. What's the probability of getting all tails? Well, you're going to have to look back at your tree or kind of think about it. To get tails 3 times in a row is actually a 1 out of 8 chance. Think about the tree, or you could do 1/2 times 1/2 times 1/2. But to get all tails, 3 tails in a row, is actually a 1/8 chance. But if that happens, you do win $10. The chance of losing then is 7/8 because everything else is a loss. 7 out of 8 chance that you would lose, okay? Times -$2. Again, let's just change these to decimals. I believe this is 0.125 times 10 plus 7/8, I think is 0.875 times -2. This is what, 1.25 plus 0.875 times 2, 1.75 negative. Okay, so if I work that out, like it's $1.25 minus $1.75 is 50 cents negative. Okay, so this means you actually lose 50 cents per play on average. Okay, I mean that's on average, right? That's saying over time you're gonna lose 50 cents per play. If you play 10 times, on average you're gonna lose $5 because I timed this by 10. If you play 100 times, you're on average gonna lose $50. So this is telling you per play, per time. That's what the expected value is. It's per play. What's the result on average for each turn or each play? Okay, and there's one other thing there, guys. There'll be that's really related. It's a weighted average thing. Where the last problem on your homework looks like this. There'll be it's like you're in college. You got these classes: bio lab, and math. You got to take math again, huh? These are the credits. Sorry, this is credits. You'll have like a 3-credit class. Bio lab maybe meets only once a week kind of thing, so it's a 1-credit class. And math maybe meets 4 times a week, 4-credit class. So kind of like how many times you meet per week or how many hours you spend in class per week is your credits. Not like high school where everything's the same credits. This is your grade. So you got 3.5 in bio, you got 4.0 in bio lab, you're good at bio, not so good at math, 2.0. I say, what's your final grade? Oh boy, what's your final grade? Because you can't just, you say, okay, average these 3 numbers. No, it doesn't work like that because this one carries more weight, this one doesn't carry very much weight, so you can't just average these 2. This is called a weighted average. All right, so what I say is it's a lot like the expected value to take, but instead of probability, I'm going to say, hey, the credits, 3, how many credits are here total? 8, right? So 3 out of 8, for that grade I got 3.5. Okay, 1 out of 8 for bio lab, it's 1 out of the 8 credits, times that by your 4.0. And then 4 out of your 8 credits came from math, and that was a 2.0. Again, I would just change these all to decimals. This is 0.375, 0.125, 4.0, and then obviously 0.5 times 2.0. All right, let's calculate that out. I'm going to round to the nearest hundredth. And then this is just 1, I believe, here at the end. Okay, looking like we're at, what, 2.81? Does that make sense? Okay, if my math is right, 2.81. You say, man, I thought I did better than that. I got an A in bio lab. I got basically an A or A minus in bio. Why is my grade point only like a, whatever, C or a B minus or whatever this is? Well, it's because this one had more weight, this math class. So you'd say weighted average carries more weight. It's just like you calculating your grade for your semester, The first quarter, second quarter carry 40% weight. Your exam only carries 20% weight. So it's kind of similar to that where, it's an average, but it's weighted, meaning some things are more important than others. So they move your average more. Okay, I think that's all you need there, guys. Good luck on that last assignment.